Welcome to the CLIMAX Academy Live. I'm Jim Miller, the Global Training Manager. Today we're going to be focusing on a few questions that we've received from different customers. They're not all from one customer, obviously, but different customers, and we've addressed them with them directly, of course. So if they're online today, sorry, we're covering your question again. So I've got the LM60 or 52 here as an example that we can look at while I go through some of these questions. Helpful to have a bit of a visual here. So again, if you have any questions while I'm going through this presentation or answering these questions, go ahead and go to the bottom of your screen, the Zoom Q&A, and enter your questions in there. And if I don't get to them at this session, we'll definitely address them either directly with you or we'll have another session on this. And I know we've had one session before, but these are specific for some of the things that we feel that need a little bit more explanation. So, okay, so as always, I always want to start off with safety. I want to make sure that I look around and make sure there's nothing that I'm going to trip over, or if there are cables that I'm well aware of where they're at and they're not in my direct path. I still want to make sure I take my ring and watch, and even though we don't have power to the spindle, we do have power to the axial feeds and both direction X and Y, so we can move the machine around and do some of the testing that we need to do. So I do have a pinch hazard possibility if I left the feed on, but we're not going to be running the spindle at all today. So I want to watch out for chips, pinch hazards, all those things that I would normally want to be aware of in a safety situation. So always want to look at safety that way. Okay, so now that we feel pretty comfortable about our surroundings and anything we might run into, let's go ahead and get started. And again, while we're going through this, if you have any questions at all, go ahead and go and type those in at the Q&A section, and we'll try to address those later on at the very end. So, okay, first let's go ahead and we'll start off with some of the questions that we've received. And I'll just have John read those off.
Why are bed travels limited to certain lengths?
Okay, bed travels to certain lengths. Well, what we have is the ability to build sections of bed. So we could have an infinite number of bed sections, but are limited to the length of the lead screw. So the lead screw really is what dictates the travel of the machine. And the most machines will come with 2 or 3 different lengths of lead screws, so I can build the bed sections appropriate to that. Now, in the standard configuration, I want to be able to bolt the lead screw on each end of the bed so that I can place the feed unit on the end of the lead screw. So that way I can swap my feed unit from this end of the bed to the other and have full travel of the machine, because I can't fit the feed unit internal to the end. It has to be on the end. And it has to be secured, right? It has to take the torque of the feed and all that kind of thing. Same way on the Y. But mainly it's the X we're talking about because it's a buildable bed length. So the lead screw really is what dictates the travel of the machine.
Can bed travel lengths be changed to non-standard lengths?
Yeah, no, great. I guess I didn't go far enough in that. So yeah, I can have multiple sections of bed that don't line up with my exact length of lead screw. And in that case, what I do is I make sure that I bolt the lead screw on one end of the bed so that I can still receive the feed unit. And then the other bed, or the other end of the lead screw, it has to be secured, but it doesn't necessarily have to reach the end of the bed. It can be midsection somewhere. I just can't put a feed on that end of it. So what I would do is I would have a bed section less than double the length of the lead screw, right? And so I could bolt it on one end, bolt it out in the middle. I could travel the machine over that area, unbolt take the feed off, unbolt the lead screw, slide it down to the other end so that I can get the feet on the other end, and then I can travel the remaining section. So that is a question we received several times, is can I build a longer section of bed, do my complete setup so everything's in line and perfectly, the way I want it, and then bolt the lead screw in one end, do a section, unbolt the lead screw, move it to the other end, and complete that section without having to do a complete new setup. So that is a really good question, and hopefully that's helpful to you. It gives you that just one more capability that the machine's able to do.
Can you describe general steps to set up?
Yeah, no, great. Okay, so the first thing that some people may not realize, and I'm sure you do if you've read your manual at all, and I would strongly encourage you to get the details from your manual. The manuals are online, easily downloaded. Literature's online, the manual that has all the setup details and the setup process. But as a recap, these setup plates are really key to the ability to, what I do is I basically span this over the split line of two beds, and I can draw the beds up to the bottom of this setup plate. It's really key. So the datum surface is this main surface here, that the same surface that the rail bolts to. That is my datum surface. That's the precision surface, and the internal mating line for the two beds together. Those two surfaces are the datum. That we set the rails exactly a distance from the internal, and we set the rail directly on top. So even though the rail is a precision ground rail, I'm not a big fan of trying to rely on the face of the rail as my datum. I always want to go to the surface that the rail bolts to. That's the precision surface. So I bring those bed sections up, I bolt them to this setup plate, and I bring those bed sections up and make sure that they're in line with each other. And I also, when I'm in linear mode, I bolt the beds together, and that's what sets my center line. And then if I'm in gantry mode like I am here, I have these alignment plates or these gantry plates that align the bed section. So I always want to overlap those with the split line. In other words, if I have a 4-foot bed, I'll put a 2-foot section of gantry plate, and then I have a 2-foot section of bed, and I have a 4-foot section of gantry plate. So the split line always overlaps so that I don't have both of my components at the same split line. That's something I really want to watch for. So the first thing I do is I bolt all the beds together using the alignment plates or the gantry plates, and I want to follow the manual for the torque values. I don't want them super tight. I want to be able to still make adjustments. And so I want to bolt everything together, get it loosely aligned where I want it, close to where I want it aligned, and then I complete my torquing and leveling. So I've kind of covered how I bolt the beds together, and I kind of talked about the torque values. So now let's kind of talk about some basic leveling. Again, I like to rely on my datum surface for my leveling versus the top of the rail. So what I'll do is I'll grab a precision 1, 2, 3 block. I can go over the top of the rail, and then I can use a variety of methods. I mean, I can use optics, I can use a laser tracker, I can use a tight wire, but a precision level or a water level is really the most common, the easiest to get my hands on. So I can check my x-axis, and let me talk just a little bit about how I do that. On the bed sections, there's about every 8 inches or 10 inches, there's a hold down point. I can bolt the bed to a surface or a subplate or the surface that I actually want to mount to. And then right next to that, I have a jacking screw. So I can pull down with the hold down bolt, and I can push away with the jacking screw. Well, that's how I get my movement for my leveling. So when I'm in linear mode and the beds are together, I have a pull down on each of the flanges on each side, and I have a push away on each of the flanges. So I can set my y-axis and I can set my x-axis level that way. When I'm in gantry mode and I've separated the beds, that one of the features of the gantry plates is it has an additional place to put a hold down bolt and a jacking screw. So now I can independently adjust the gantry mode side to side and length by these jacking screws. So again, I'll put my level, my precision level on the datum to get my X, and then I can turn the 1, 2, 3 block on that same datum to get my Y. So generally when I'm setting up a linear mode, I'll put the complete mill all together, set it on the surface. I can either run down the length with the indicator and the spindle, or I can do this leveling process. But I'll center it and I'll level it all together, all as one unit. When I'm in gantry, what I try to do is I'll place one bed section, get it fairly aligned with where I want to go, and then I'll secure it down. Then I'll go ahead and put my second rail, my second bed down. I'll loosely align it, and I'll go ahead and place the ram on top of the skates. So then, without the ram, without the actual spindle and everything in, and without the lead screw in, I can then slide the saddle from one end to the other and align the two sections of bed, or the two rails of bed. I want to make sure that those are really close together, and again, in the manual it shows you what misalignment I would be allowed. But that's a good way to determine these zero friction rails they're really good for aligning the bed and really good for that movement, but they'll take a lot of force that you don't even realize, because they move so easily that if you're in a bind, it can damage either the skate or the rail. So you want to make sure they're really close. Same way on the height adjustment of them, and I'm going to give you a little demonstration here of how I check the final height of those. But so I want to make sure that I nail down that first rail. I let the second rail float while I slide the ram and the saddle full length, and then I can start tightening things down to make sure that everything's in line. So that's how I approach that. So then once I get that all pretty good, then I do my final level. And in what I like to do when I have a gantry is I look for a precision parallel or a nice big straight bar that I can span the gantry, and then I can check it because what I'm doing is I'm lining each side up to each other, and then I'm moving the whole thing as a unit to make sure that it's level. So hopefully that's helpful. I know I kind of went through that a little bit quickly. If we're in a person-to-person training, or if you're with a trainer live, you can really get your hands on this and really have a chance to experiment and play with it, and really that's how I learn the best, is by actually doing so. Hopefully I've covered that well enough that it makes sense. Okay, so do we want to? Okay, I'll go ahead and demonstrate here at this point. How I want to, because I have to have these rails the same height within 1/1000ths. What I'll do is I'll just set up a height gauge with an indicator, and this is just a precision ground height block that I can adjust, and I'll just slide that right up against the rail, and then I can travel that. I can just slide that right along that surface and make sure, make sure that I don't have more than a 1/1000th difference between that split line from one side to the other. And if I do, I have to keep adjusting that until it's straight. Because if those are out of line with each other, it could end up damaging the skates themselves. So hopefully I've covered that well enough. And again, if I haven't, please give me another question so I can clear that up.
What does it mean to train the spindle?
Okay, good. Yeah. So we use this term tramming. It's kind of a weird term, right? Well, basically what that means is we're making the spindle perfectly perpendicular to an axis. Okay, so we have an x-axis, which is the long travel typically on any milling machine, and a y-axis, which is typically the cross-axis on a milling machine. So I want to make sure that that spindle is perfectly perpendicular, because if it's not, I'll take a cut, I'll move over, take another cut, and I'll have like a sawtooth. I'll have a difference in height because the angle of the cutter isn't perfect. So every time I move over, I'll have a step that I can't get rid of because I would have to adjust my height, and I just can't adjust my height out of that. So it's really important that I be able to dial indicate that spindle perfectly perpendicular so that I have a smooth transition from one move to the next. So I've got the spindle mounted to the cross saddle. I have 4 bolts that hold the quill housing to that cross saddle. And then I have 4 jacking screws, similar to the ones that are on the bed, that allow me to adjust for pitch and yaw from front to back. So first we'll talk about the y-axis adjustment. I want these bolts snug. You know, I know that's kind of a loose term, but I want to be able to have it hold where I put it and yet still be able to make a fine adjustment. So I'll have that setting, and then on the top of the plate that holds the quill housing to the saddle, I have adjustment screws. So I can push down on one side and pull the spindle that way, or I can push down on the other side, because this relies on a center pin that allows me to adjust that. So this set screw right here will allow me to make an adjustment side to side. So the first thing I do is I take my indicator setup and I put that with a mag base right onto my spindle. Now again, I don't have a motor in here. I wouldn't be able to rotate this by hand. I put that mag base on there and I put a test indicator pointing up. What I'm going to do is I'm going to sweep that from one side to the other, and I'm going to ensure that the spindle is the same reading from one side of the saddle to the other, or the ram to the other. Because the bottom of this ram is a precision surface that we perfectly align the rails to, and the rail is what gives us our travel. So if I indicate to the bottom of the ram, I can guarantee that the travel of the machine is perfect from one side to the other. So I'll just swing this around with the indicator in the spindle. I'll come and touch the bottom of the ram, make sure that I set my indicator to 0. Then I'll swing my indicator. Now the farther I can span that indicator, the more precision it'll be. The closer it gets, a little bit of movement extends out further. And so if I can start out with a double or triple or quadruple the diameter of the cutter with where I'm measuring, I'll have a more accurate setup or setting. So I'll go ahead and spin that around to the other side and then come to the bottom of the ram and take note of that reading. And then I want to split that difference with this adjustment screw. So I want to have a 0, 0 on each side, and once that's 0 on each side, I guarantee that the bottom of that cutter is perfectly in line with that axis. So then when I do the x-axis, I do the same thing. I put the indicator out in front of the cutter. In most cases, I can just put it right on my workpiece as long as I have a good flat surface. If not, then I can come right to the top of the bed rail. I go to the front, and then I slide, and then I go around and I go to the back. And I make sure that I'm good from front to back, same way, 0, 0. Now the front to back is not quite as critical as side to side. Front to back will give me just a slight belly in the cut. Basically, I'll have a healing effect where the cutter will cut on one side of the cutter and clear on the other. That's not as critical in most cases. It's not something that's going to really affect the surface unless it's a long ways out. But anyway, I think I've covered that pretty thoroughly at this point. So hopefully.
Can I move the spindle from either side of the bed?
Yes, great question. So when I'm in the linear mode and both beds are together, that's how I operate the mill. The mill is out one side, I do my work, and that's generally what I'm trying to accomplish. But there are cases where I want to set the bed in linear mode between two mounts. Say I'm doing a motor mount or a pump base, and I have pads on either side of the where I place the mill that I want at the same plane. So I can do my precision setup, all my alignment, set my ram to a position where I can machine on one side, pull the cutter out, travel over the bed, put the cutter back in, and now again machine on the other side without having to make any movements to my setup. And that's what gives me a precision setup, is that I don't move any components. As soon as I move a component, then I run the risk of getting something under it, getting a chip, getting a ding or whatever, and throwing off my setup. So then I would have to go through my whole alignment process again, or a leveling process again. So as long as I can keep my components without moving them and just travel the head from one side to the other, then I can ensure that I have a great, a good setup. Now when I'm in linear mode, my idea or my purpose usually is that I separate the beds so that I can machine between the two beds. However, if I need to, and that's the beauty of these machines, they're so versatile, they can be set up in multiple ways. I can set the ram in such a position that I can machine between the beds, and then I can move the spindle to outside the beds and machine another surface outside. So, in other words, when I set my bed distance from each other, as long as they're less than the length of my travel of my ram, I can go extend on outside of the beds or machine inside of the beds. So I can purposefully set the beds a little closer together so I have extra travel on either side of the outside and still be machining on the inside. Makes it a tremendously versatile machine. And of course, I can always flip the head over and machine above my whole amount of travel. Or I can invert the whole machine and then machine below that whole surface. So really does open up a lot of possibilities for how I can mount the machine versus how I need to use the machine. Okay, well those are the questions that we had received from our last session together, or not our last session, but over a period of time. And I'm just wondering do we have any further questions today, John? No. Okay, well great, that's good. Hopefully that means that we've done a good job of covering this topic. But again, if there's something that doesn't quite make sense and you want us to explore it a little further, go ahead and send those questions to askcpmt@cpmt.com, and somebody will get back to you. We'll answer that question directly to you, or we'll log it away and put it in another session that we might have together as a group. So I really appreciate your time this morning, and morning for us anyway. And I hopefully you have a great day and be safe out there, and we'll be talking to you next time.